What we're gonna do today is as follows. Please make sure to look at your screen now. We're gonna learn how to combine two functions because it's part of working with rational expressions. Just give me a second, take a look at the screen now. Okay. I'm wondering how it's gonna work for me since I'm done. Okay. Yeah. So for those of you who are not confident in their skills or just joined, you have to send me an email by the end of today. So I have a list of students. And also, I'm gonna send you a mail to all of you when we have makeup classes. I'm pretty sure we're gonna have those makeup classes Monday, Tuesday, two classes before Wednesday, so you can prepare for the test. Okay? And Monday and Tuesday, we're going to practice um, wherever you have problems with. Okay? Is that clear? No problem. We're gonna conduct makeup classes at the evening because at the day most of you have school. So we're gonna conduct them, I believe, around 5 to 7 p.m. I'm not sure. I'm gonna let you know once I get a list of students who require assistance. Oh, I hope you got enough time to take a look at the screen and see what we're doing right here. Please make sure to write together with me because this is gonna be part of your submission in the Google Classroom. So in particular, we're going to talk about combining two functions, sums and differences. Functions can be combined in a variety of ways. Addition and subtraction of functions is one way we can combine two or more functions. To add or subtract two functions, f of x and g of x, we can do the following way. Add, subtract y values for matching x values, and graph the new set of points. Secondly, algebraically add, subtract the two functions and graph the new function. So what they say is basically scenario number one, we have value y1 and let's say y2 of two functions. And we have a table of values for points y and x. So basically, if we add two functions, we add those two values for y, and we add corresponding values of x, which gives us, x value should match for them. So x, they share same x, and we add y values for them, but they share same x value, okay? The second algebraical approach is more interesting as for me. In this case, let's say we have two functions, f of x and g of x. And algebraically, we're going to add or subtract these two functions, which would give us the new result. If we add them, we're going to get f plus g of x. If we subtract them, we're going to get f minus g of x. As you can see here, this is f plus g of x, this is f minus g of x. Is that clear for now? Now we're going to take a look how we can do that. No questions? Okay, silence means no for me. And then what we're going to do next is solve example number 1. Example number 1 gives us f of x 3x squared plus 2, which is quadratic functions, right? And g of x is 1 over x minus 4, which is reciprocal function. So let's try f plus g of x. Basically what we're doing is f of x plus g of x would give us the following result. We rewrite f of x as we have it here, 3x squared plus 2 plus 1 over x minus 4. So basically, it's not a simplified form of it. In order to do so, we need to get rid of the denominator. Or basically, simplify it as much as possible. What we can do here is, let's see. Basically, right now, in this case, there is not much we can do. We're just combining these two functions in the one form, because, for example, if I'll try to multiply it and divide it by something that won't affect the equality, it would have to be like something x minus 4 over x minus 4, right? But it makes no sense because it's just 1. We won't get any particular result from it. So in this case, this would be the final form of combining two functions. For f of x minus g of x, f minus g of x, we're gonna have pretty much the same stuff, but now we're gonna have minus here. It's just like with regular numbers, right? We have minus 1 over x minus 4. Is that clear? Okay, great. Now we have to talk about the domain of f plus g of x. What can we tell about the domain of this function? Range of this function is not quite clear for me yet, but the domain is mostly defined by those values that x could take. Domain is horizontal line, right? Remember that. And in this particular case, you remember that denominator could never be equal to 0 for us. So in this scenario, I can tell that domain is as follows, that x, e are all rational numbers, but at the same time x does not equals to 4, because if x equals 4, denominator in this part of my function is going to be equal to 0, and that's what I don't want to see. Take notice that separately f of x and g of x, they have different domains. For example, f of x has a limited domain. Meanwhile, g of x has this limitation of x does not equal 4. But combining them together brings this property to the shared function. D, we have to evaluate f plus g of 1 when x equals 1. So let's say 3x, so I'm going to write how it's supposed to be right away. So it's going to be 3 times 1 squared. Let's write it for now so you have an idea. Plus 2 plus 1 divided by 1 minus 4. It should be fairly easy to evaluate it. So 3 times 1 squared is 1. 3 plus 2 is 5. 5 plus 1 over negative 3. So negative 1/3. And 1/3 we can express as 3.3 in period. So I would just say, if it's 5, let's say it's 4 and 2/3. Do you agree with me? 4 and 2/3. Anybody? Can you check if it's right? I'm waiting for you guys. Okay, while I'm waiting for everybody, I want to let you know that before our makeup classes tomorrow and day after, you should go through the home assignments in the Google Classroom related to rational functions so you can prepare for the test. And while going through those assignments, note down numbers of questions where you don't know how to do them, so we can go through them in the class together. Is it clear, Ayah? Great. Okay, so I believe everybody agrees there's going to be 4 and 2/3. Okay, I'm going to clear the desk now. Does anybody needs more time to copy it? Okay, I'm clearing the drawing. Ah, 1 second. Okay, I can return it. So in the last one, I just substituted x equals 1. You see, this is my initial expression, and instead of x here, I just put 1. That's how I got this part. Now it's 3 times 1 squared plus 2 plus 1 over 1 minus 4. 3 plus 2 is 5, plus negative 1 over 3 gives us 4 and 2 over 3. Can I move on? Great, thank you. So example number 2. Given f of x and g of x below, determine the equations of f plus g of x, f minus g of x, state the domain for both of those functions, and graph each function. Let's start with writing down the combination of those two functions. So f plus g of x, please write down with me together. F of x is x squared, so x squared, and g of x is 2x plus 2x. So you got this nice quadratic function. For f minus g of x, we're gonna have x squared minus 2 of x. Okay? Now, once we got this, let's talk about the domain for these functions. Any suggestions? I would say the domain for both of these functions is all rational numbers, no limitations for that. As for every quadratic function. So x, e, r for both of them. And we could also say that x lays in interval from positive infinity to negative infinity. Or from negative infinity to positive infinity would be more proper way of saying that. From negative side to positive side. So no limitations on x-axis. Is that correct? Now, knowing all of this, we need to graph each of these functions. I believe you should know how to graph parabola, quadratic function. No? So first of all, let's show zeros of these two functions. How do I do that? Easiest way is to extract x outside, factor it into the factored form. So we're gonna get x plus 2. Here we're gonna get x and x minus 2. This is our factored form. So now we know we have two zeros. In the first one, we have 0 and -2. In second one, we have 0 and +2. These are going to be two zeros of our function. So these are the points where the when y equals 0, so it's x intersections, right? So we're crossing x-axis. For first one, it's going to be happening in 0 and -2. This is where we cross the x-axis, x-intercept. And for second one, it would be 0. I'm going to use the blue color for that. Going to be also going to be 0 and 2. Sketching the graph number 1. What else do we need? We need a vertex, right? How do we find the vertex of quadratic functions? Can anybody tell me that? I'm going to wait for your answer now. Anybody? First one may have extra. Guys, how do you find vertex? Okay, first of all, I would tell you that this function, quadratic function, is going to be opening upwards because leading coefficient is non-negative. As you can see in front of x squared, we have no minus, which means parabola going to face upwards. Minus b over 2a, great. That's actually a good formula for vertex. Good to remember that one. Minus b over 2a. Good job. So for number 1, minus b is -2. -2 over 2a. A is 1. So -2 over 2. So we're going to get -1 for the first one. And for second function, I'm going to write it somewhere here. You're going to have 2 over 2. So it's going to be 1. Is it? Yes. So this is not particularly a vertex, but the axis of symmetry that we find using this method. So for red one, our axis of symmetry is going to be here. Going to be on this line. And for blue graph number 2, the axis of symmetry will be here. Now, in order to find vertex, we have to solve this function. First one, let me clear the domain. They're going to write it here. For the first one, we're going to have y equals -1 equals x squared plus 2x. Now basically we have to solve it as x squared plus 2x plus 1 equals 0. So we would get quadratic functions that we have to solve. And best way I prefer is to sort discriminant. This would be b squared minus 4ac. So it's gonna be 4 minus 4. And it's great for us because it means discriminant equals 0, which means the square root of discriminant equals 0. So we have only one solution. So x2 and x1 gonna be minus b plus minus square root of discriminant, which is 0, so it doesn't make any effect for us, over 2a. Which gives us, okay, I see. Yes, you're right. We substitute -1 for x. Good notice. I'm sorry, I just got a little rushed here. Yeah. So yeah, this is not right stuff to do. So we just substitute -1 and 1 for x and find the y value instead. I messed it up. Thank you for noticing that. So you're gonna substitute -1 into f of x. So basically you're gonna solve for f of -1, which will give us -1 times -1 plus 2, which gives us -1 times 1, which gives us -1. And for second function, we're gonna have g of x equals g of 1, because here the other axis of symmetry, which equals to 1 times 1 minus 2, which also gives us -1 as an output. So now I clearly can tell that for f of x, my vertex is going to be at point -1, -1. And for g of x, my vertex is going to be at 1, -1. Does everybody agree with that? Now, even using those 3 points, I already can sketch these two parabolas. If you want to be more precise, you could take few more points to the left and right hand side from vertex in order to be more precise, but I'm going to do it like this. All right? Here. Isn't it beautiful? Now we reviewed algorithm on how to sketch graphs. Also, we've seen how combining graphs can drastically change the image that you get. For example, f of x and g of x solely, let's show f of x would be just parabola like this with the green color, and g of x, this purple color, g of x 2x is gonna be just a straight line, right? So if x equals 1, it equals 2, 3, it equals 6. It's going to be a straight line passing like that. But now you see combining those two functions gives us offset parabola. Any questions on this one, on this example? I hope it's clear. It's been fairly simple and you guys did a great job. Ayach, I'm proud that you found my mistake before I did. Okay, take a moment to copy it down if you still need time, or can I move on? Okay, let's move on. This example, please guys, do it on your own right now. So we need to find the f of x, f plus g of x, and sketch it, as well as f minus g of x. Let me see. Yep. This fairly simple example, but now we have exponential function. So f plus g of x would be 2x minus 3. Meanwhile, this would give us 2 to the power x plus 3. Because minus on top of minus gives us plus. Now we just need to recall how exponential function looks like. I believe you covered it in a grade 11. So I give you an idea. Exponential function would look like this. But notice that these exponential functions are slightly offset, right? Minus 3 plus 3. Think about it. It's going to be fairly easy for you. Question is the same. Determine the equations. I already did it. State the domain. That's what you have to do. And graph each function. State the domain and graph each function. If you want me to zoom out, I can do that. But is this better now? Okay, take around 5 minutes on this one, and once I got back to you, I'll ask one of you to show me the graphs that you got, okay? Okay, guys, any results so far? Okay, and then I'm gonna show you how I would do it. So as I've said, exponential function usually have the same shape and form. It's a elevating line that never crosses the x-axis. For some cases, if it's just 2 to the power x, because there is no way to make this number negative. Even if x is a very big negative number, like -1000, it's just gonna be 1 divided by 2 to the power 1000, which gives us incredibly small number that travels to 0. So it's gonna approach the horizontal axis. But see, our functions are modified. First one is 2x plus 3. So it's basically translated 3 units upwards. And the second one, 2x minus 3. So basically translated 3 units downwards. So what I'm going to do, first of all, let's say the domain for these two functions. Domain is x er, and also x lays on the interval from negative infinity to positive infinity. So all rational numbers we can use. Secondly, how would I sketch this graph? I would use a technique of translation as I suggested. So let's pick 3 points to sketch this graph. First one when x equals 0. Second one when x equals, let's say, 2. And the third one when x equals, let's say, -2. So x equals 0 for, let's just sketch 2x, and then we translate it. 2x, x equals 0 would give us 1. So it's point right here. Then x equals 2 is going to be 4, x2, y4, point going to be right here. And -2 would gives us 1 over 4, right? So -2 and 1 over 4 is 1/4, somewhere here. So we got our 3 points that we're going to join gently, like the smooth curve, like this. So this is our initial graph of exponential function. Now, what I'm gonna do for first scenario, I'm gonna move each one of these points 3 units upwards. So it was 4, now it's gonna be, so I'm gonna use red for this one. It was 4, now it's gonna be 7. It was 1, now it's gonna be 4. It was 1 over 4, now it's gonna be 3 and 1 over 4, somewhere here. And we join these 3 dots in the same way. Something like that. I'm not really good at drawing. This is the first one. And the second one, I'm going to use the blue color. We're going to do the same thing, but move it 3 units down. So it's going to be, here is going to be 2 3/4. -2 3/4. Here it was 1. It's going to turn into -2. Here it was 4. It's going to turn into 1. And I joined these 3 dots the same manner. All right. Does everybody got the same result? Great. So take a moment to copy this down, and we'll move on. Okay, guys, I believe I gave you enough time to copy everything down, and we're going to move on to example number 3. Given the graphs of f of x and g of x, determine the graph of f plus g of x and f minus g of x. Okay, in this particular example, it should be fairly simple because, as you can see, we have two linear functions, right? F of x and g of x. But you may ask me, how do we find out what equation is that initially? And I would tell you that you have to look for x-intercepts as well as y-intercepts, as well as their mutual points of contact. And let's start with small things. For the red graph, I'm going to use the red pen. I see that I have point x0, y0, x equals 0, y equals 0. Then I see they have one intersection point where they share solution, but I don't know where exactly this point is, so let's leave it for now. For blue graph, I see that I have x-intercept as well as y-intercept. Y-intercept is y equals 5, x equals 0. Also, x-intercept is going to be y equals 0, x equals 2.5. Okay. So now we have to remember, how does the linear function looks like in general? And any function f of x that is linear gonna have a form of k times x plus b. This is a general form for linear function. Now, let's start with blue one. For blue one, we know two pairs of points. First one, 5, when y equals 5, 5 equals k times 0 plus b, because x equals 0. Another point that we know is 0 equals k times 2.5 plus b. Now, I have the system of equation that could help me to find b and k coefficients. Does everybody understand what I'm doing here? Before I move on, any questions? How did I do this? Okay, I'll treat it as no. So from first one, I can see that k times 0 is just going to simply be 0. So I can say that 5 equals b. And I already found b. b equals 5, right? Now, I substitute it into the second one because it's system of equations. Substituting it into this one would give me k times 2.5 plus 5 equals 0, right? Now let me continue my solution here where I have more space. Now I say k times 2.5 plus 5 equals 0. Now I say k times 2.5 equals -5. Now k equals -5 divided by 2.5, which gives us how much? 5 divided by 2.5 gives me 2 and -2. So it's going to be k equals -2. Now, I already found one of the linear functions, the blue one. Now I can rewrite it here. The blue one would be y equals -2 times x plus 5. I found one of these two equations. And now, what about the red one? Red one should be f of x equals k times x plus b. But we know one solution for this function. When x equals 0, y equals 0 as well. So using that, we can say 0 equals k times 0 plus b. Considering that, I can say that b, in this case, equals 0. Because this is the only way for this to be equal to each other. So for this equation, I know that b equals 0, in fact. Okay. So we have a linear function that looks like y equals k times x. But what is this k coefficient? How do we find it? We know that this function and this function, they have common solutions where x and y point coincide for them. So what do we do? We should find solution when this part equals to this part. So when they're equal. So we say -2x plus 5 equals k times x, I think, for same x value. Let's think for a moment here. What can we do? I'm waiting for your suggestions in the chat. In reality, it's much more easier here. You don't really need to figure something out with this one because you can't. You have two unknown variables, and there is no way to solve this right now for you. So what I would do is I would look at the red linear function. What does it tell us? It is obvious in this sketch that this linear function has following equality. You see, x equals 2, y equals 2. X equals 4, y equals 4. So basically, when x equals 0, y equals 0 as well. So what we can conclude that the red graph is in fact function that looks like f of x equals x, or y equals x. So it passes the coordinate axis at 45-degree angle. And blue one, as we discovered prior, the moment before, is y equals -2x plus 5. Right? So now, using the graphs and points that we can identify on them, we figured out two of these functions. One of them is y equals 2 minus 2x plus 5, and the other one is y equals x. So what we do here now is we have to find graphs of f plus g of x and f minus g of x. F plus g of x would be x plus negative 2x plus 5, and minus f minus g of x is going to be x minus negative 2 times x minus 5. Keep in mind that when we are doing it that way, we're basically opening the brackets. So we have to apply minus to every sign in there. So g of x is negative 2x plus 5. So when we subtract this from f of x, we have to apply minus in front of negative 2 and in front of 5 as well. So simplifying it would give us x plus 2x minus 5, or 3x minus 5. And the first one would give us x minus 2x plus 5, which gives us negative x plus 5. Or for convenience, you can swap them in the places, but not necessarily. Now, let me clear the drawing a little bit so we can sketch our graphs here. First of all, talking about domain. Domain is unlimited here. So x, e, r, and r, and x lays in between negative infinity all the way to the positive infinity. Considering that, let's sketch the first graph. You can see it still has a linear dependence. So it's sufficient for us to take 2 points. I suggest we take 0 and 1 for convenience. 0 what gives us 5. 0 and 5, and 1 would give us 1 and 4. Oh, not here, but here. 1 and 4. So just sketching a straight line through these 2 points, like this, what gives us graph of f of x plus g of x. Now for the second one, I'm going to use the blue color for f of x minus g of x. Okay, let me know. This is f of plus g of x. And for second one, use the blue color. We have points 0 and 1 as well. Let's keep it simple for convenience. So it's going to be when x equals 0, y equals negative 5. This is where our final expression. So somewhere below 0 and negative 5. And for 1, we would have negative 2. When x equals 1, 3 minus 5 is negative 2. Is that correct? So result, we're getting this like linear function. In reality, it would be going a little lower, but the graph is not endless, and I cannot go down to negative 5, but I hope you got an idea. Any questions so far, guys? This is the right moment for you to ask questions, because now I'm going to post links to other lectures, classes that I want you to work through on your own for another half an hour. And for those of you who have troubles with homework, you can spend this time for your homework. And I strongly recommend that. We still have another half an hour left for this class.